What? Wait, why is my camera off? Oh, man, I don't like craziness. Did I do this to myself? No, the camera's off. What is going on? Good morning, Noel. Why did the camera reset? I don't like weird things. I don't like weird. Why is the camera reset? What is going on? What is going on? Oh, it's been a weird morning. It's been a weird... I know, right? The camera's been either reset or something. Somehow something went weird. Oh my gosh. I don't know. Ah, I see there's too far. There's my umbrella. Oh, here we go. Can I nudge it up? Oh, that's not right. Why did it do that? I don't know. I don't like weird. I don't like weird. And also, it's like... I feel like it's zoomed wrong. It's zoomed in wrong. So it zoomed... Like, the resets. I reset, so now I'm all zoomed out. Okay, so let's zoom in. Oh, there we go. There's more zoomed in. And then... I don't know. Now we got... So the problem is this actually... Or maybe I just need to click preset 1. It didn't load a preset. Let's click preset 1. Oh, there we go. So actually, we did still have preset 1 in here. Preset 2. Whoa. Welcome to the studio. It looks okay now. I just need to do this next class. Like, welcome to Studio 1. Do you think I should just do this? Just be like, hey, everybody. Welcome to the class. Just do this. Let's see, preset 3. There's no preset 3. There's just preset 1. I know, right? Looks like I'm in some sort of like... I could just do the weather back here. So there's the studio. There's the behind the scenes. Yeah, so I think we got the preset done. I don't know why it did that. So preset 1 was still locked. It's like someone adjusted the camera, or the camera just... It didn't log in preset 1. It's just been a crazy morning. Let's show you picture in picture with Brian right there. Making sure the other presets are fine. So my presets are saved. Now I'm just on the screen. Oh yeah, let's head back. Do it. Whee! Welcome to Stat 1. There's the office door. Cool. It's neat that those... Thank you to Dwight who helped us set this up. Should we do the data analytics? What should we do? I don't like... Oh, they reset power here or something, so maybe that's what it did. Maybe it didn't grab the... I don't know. Who knows what's going on? Who knows? Chapter 8 quiz, then the data? Yeah, let's do Chapter 8 quiz. Which one on Chapter 8 quiz? What should we do on Chapter 8 quiz? Little chill music right here. Chill music. 3 questions? Yeah, let's do them. Let's do all 3 of them. Let's do all 3 questions. All 3 questions. I need to probably grab some lunch today. An analyst trying to fitting the regression line to each segment. Ooh. We're doing like piecewise regression right there. Chapter 8 quiz. We only have 2 days. If you're a Haslam student, there's only 2 days this week, really. I'll double check. We're getting Chapter 8 loaded up. There we go. Regression modeling. Zoom. MIT. What do I have MIT? I don't think MIT on Friday. MIT. Okay. Let's load up this Chapter 8 quiz. Assignment Manager, I don't love it because I don't like the way it shows it to me nowadays. I just want to see my assignments. Scatterplot looks crazy graph and it confuses you. Oh no. Okay, let's see. An analyst tried fitting the regression line. Okay, I've got the quiz up. And let's head over to the main screen. Let me pull up the office hours notes. Okay, an analyst tried fitting the regression line. They tried fitting a regression line. An analyst tried fitting the regression line. Here we are. Let's mark it in the notes at the 8:13 mark. Stat Tool 1, Chapter 8 quiz. He's still down. He's still down. It's I tried downloading it again before we started, and it still says it's a virus. And I'm waiting for one of my tech people to come back and say, yeah, download it, or no, what are you doing? Don't download that. So I'm trying to find out. Okay, here it is. They're going to fit a segmented line to this data. And so what they're doing right here is you can see is there any agreement on this. Like if you look at this graphic, are these lines similar or different? Like, do all these lines look very similar or do they look very different? What is your thoughts? Do all these lines look very similar or different? Well, take a look at the flat line. Take a look. So this line right here, though I'm highlighting in yellow, has a big slope. And when you compare these two lines, you've got a line that looks like that, which is flat, which means no relationship. Then you got a line like this, which is pretty strong. So there's a lot of variation between how they fit these lines and what they get. Actually, and even one of them has a what slope. Even one of them has a what slope. If you see that one right there, it has a what slope, which we could put it over here. One of them has a what slope. So one of them has a very what slope. Negative. Great job, Kenai, right there. And there are some that look similar. There are some that look similar. I totally agree. Great answer right there. But we have a negative slope, a zero slope, and a positive slope between all these different lines. So with that in mind, depending on how they fit the line to the data, you're getting a lot of differing results. So with this right here, they follow very different relationships. No, each line segment has a different best fit. So do we think this is correct? They follow different relationships. So, oh no! Wait, what does this say? The model being tested gives predicted January value is equal to this. What does this say about the analyst's concerns? Oh wait, were they justified in worrying? Were they justified in worrying? So what should the answer be? A, B, or D? Were they justified in worrying? You see, I should see what they're asking. What should the answer be? A, B, or D? Were they justified in worrying? They were worried that the data has different patterns to it and fitting different lines would show this. And they had this worry that fitting different lines would show different patterns. Yes, each one has a different fit. So they follow different relationships. Yes, great answer right there. That is correct. So literally, I thought, should they be doing this? And the answer to should they use their model is no, because the data shows different patterns. So it's only that first part right there where were they justified in worrying. So what they're worried about is there's like group A, group B, and they're like the red or the green. And the green has a downward pattern where the red has an upwards pattern. So they're worried that their overall model is not indicative of the trends. This really isn't a good test question, at least from this right here. You should know that 612.07 is the what? 612.07 is the what of the model. And they're even doing indicator regression. So 612.07 is the what of the model. You should definitely know that from this right here. 612.07, you should know that like this. I'm making more of like what you need to know for the test. 612.07 is the what? We have to know this. Only talking about like what I would, it is the intercept. Yep. That's the y-intercept. So this is the value of B0. This is the value of B1. That is the value of X. This is the predicted Y value. And so they are doing like indicator regression right here. So I don't love this. And they're actually, it's a little bit, yeah, they're making a, I don't love the way they ask this, but you should note this is the intercept plus the slope times the X variable. And this is the predicted Y value. So they're predicting profit for January or something like that. And it's an okay question. It just gets into, you should look at your data. There's a few other ones that say like, you should look at your data. And what other ones are there? Give me other questions. And if you're in here right now, we can just do any of these. We've done a lot during office hours already. A lot of them are similar to the homework questions. This one right here, we could do this one really quickly as we get another question. So I'll do this one real quick. My hair's getting staticky. Okay, SNIP 201, chapter 8 quiz. Let's do that one next. You got it. A concert production company. Okay. So in this one, someone does not want to offer advanced sales. So if they don't want to offer advanced sales, what would their advanced sales be? If they say, I'm not doing advanced sales, all you have to do is type one number in the chat. What would their advanced sales be? They say, I'm not doing advanced sales. Well, then we know what their advanced sales would be. So what would the advanced sales be of an artist who says, no advanced sales? Say, I'm not doing it. What would the advanced sales of an artist be? So that's the X variable on this. What is the advanced sales of an artist who says, I'm not doing advanced sales? I'm not doing it. Not going to happen. Wouldn't be prudent. Any guesses on what the advanced sales of an artist? It'd be 0. Yep. So they'd be down here. And the problem is you have a model going through the data here, and to go to 0, you actually have to what your model. So to get to 0, to make predictions at 0, which we would actually get a prediction at 0 down here somewhere, you actually have to what your model outside the X bounds by which the model was created within. You have to what your model to predict at 0, and you'd be like, man, total revenue is gonna be negative. So you actually have to extrapolate the model. So there's no data in that boundary, so we shouldn't use this model to predict for an artist who wants to do advanced sales. So the answer is going to be the point, the X value is far away, so it is far away from the rest of the data from advanced sales, because that's what we're using the X predict on. Therefore, the model, the extrapolation is not valid. So I just sent someone a key for this. Would it be wise to use the model? It's just like, I'm gonna say the model is not valid. But it might be we are extrapolating to where the model is not valid, so I'm going with that. Really? Really? What did I do wrong? To find the model for total revenue. Man, I should really read questions. I just sent someone a video on this where I got it right. So let me repeat it again. Wow, that's our big mess up of the day. The point is far away from the ones used to find the model for, because we are trying to find, should read the full thing, we're trying to find total revenue, but it is far away from its value in advanced sales. It's a high leverage point, but you didn't know that, my Pearson. But it's far away in terms of advanced sales to find the total revenue, and the extrapolation is not valid. Like, since we're going that far away, like, you could extrapolate a little bit is what they're getting at. It's really, and if you notice where I put the model, I even extended the model a little bit here to where it's like, it's really not a big issue. Can you explain how you tell it was the advanced sales, not the revenue? I made a mistake, and the way they're wording this, the way it's worded right here, and none of the test questions get this weird on the wording. The ones used to find, what are we trying to find here? Are we trying to find advanced sales, or are we trying to find the revenue with this model? What is the variable of interest? Are we trying to find sales or revenue with our model? So the model is meant to find either sales or revenue. It's meant to find revenue, because revenue is the Y variable of interest. Good to see you there, Mitchell. We're gonna do that next, Mitchell. You got it. We got one more question, I believe. So, or two more, and then we're gonna do some data analytics 5. Thank you, Mitchell, for being here. I wish Mubot was here to give you points, but I can give you a wow.
Wow.
I got those today. No points from Mubot though. Okay, there's evidence that age at which women get married has changed. And I think we have one more. Thank you, Noel, there it is. Okay, let's take a look. Let's not make any more mistakes. Let's get it all correct. Okay, we are here at 1713, Stat 201, Chapter 8 quiz. Is there evidence that the age? Okay, so let's look at this and see if there's evidence in a trend right here. And we'll be doing that to Analyst 5 in about 10 minutes, maybe 5-10 minutes. Oh, wow. What's the major problem with the 4 conditions of regression? What is the major problem with the 4 conditions of regression right here? What is the major problem with one of the 4 conditions of regression? It just screams. I want you to answer in the chat. You should know the 4 conditions of regression. I'll say them here in a moment, but there is such a huge problem with this one. What is the major problem with one of the 4 conditions of regression? If we showed this on the test, there should be one that you just say, yeah, there's a huge problem with this one. What's the major problem? So think through the 4 conditions of regression they should have memorized. I'll repeat them here in a moment. Which one of them has a huge problem? Just crazy big problem. Which you will be doing this for Data Analytics 5, so you got to know them. 4 conditions for regression. I'll say them about 10 seconds if no one takes a guess. Linearity, correct. QQ straight enough. No outliers. Plot doesn't think. Great job, Noel and Kenai right there. So if you try to fit a line to this, there's no line that will go through the data properly. And it's because it has a very non-linear pattern. And you can see the non-linear trend. And it goes kind of linear at about 1970. it kind of levels out between the 40s and the 50s, or the 40s and the 70s, and it might have a downward trend going from 1900. There we go. So I think that's what they're going to get into, is this is a huge problem with linearity. Let's see what we can say about it. And is there a clear pattern? Okay. So it appears to be linear up to about, no. The trend appears to be nonlinear throughout. It's pretty good. The trend appears to be nonlinear up to 1970 from, okay, there we go. Remember how I said from about 1970, it appears to be linear? So that's where they're saying from about there forward, it is linear for somewhat, not perfectly, but yes, maybe about 1970, it appears to be linear. Good. Is there a strong association? What do you think? A, B, or C? Just type A, B, or C in the chat. Is there a strong association? A, B, or C? A, B, or C? Is there a strong association? Is there a strong association? A, B, well, strong, weak, or can't tell. It was strong, weak, or can't tell. What do you think? The answer to this one is very clear. And if you're remembering what strength is vertical scatter. I like to ask this question a lot of times. It's actually super duper strong. So which of these graphics is stronger, A or B? Is A or B stronger over there? Is A or B stronger? Is A or B stronger? This is a good test of understanding strength. It is B, because the vertical scatter is tighter. The vertical scatter is how strong it is, and it's tighter. Strength is tightness, and so this is super duper strong. It's relatively strong. I'd say it's very strong. It's very tight around the form by which it was created. Is the correlation high? Here's where we run into a problem. Correlation only measures linear strength, and I think they're getting into that. No, as the whole graph is clearly not linear. Is a linear model appropriate? No, a linear model would not be appropriate throughout, although one could fit a linear model from 1974, 1975 to 2003. So I think that's got it. I think that should be good. Come on, 100. There we go. That was a very good question. That was all about linearity, basically, just understanding if things are linear, not linear. The whole point of that question. One more. What else we got? Noel, what else we got? That was pretty good. It was just all about, like I said, linearity. And then I think I got one more. And then we're going to do some Chapter 5 data analytics, but drop other questions in the chat if you got them. Go to Studio Tour mode. I can't now because I don't got it open. What else you got? A few more questions. Facebook. Not going back to Facebook. Look over there. What other questions? I think there was one more. I'll fall asleep. Get Red Bull. The Scatterplot below shows the gestation periods of life expectancies of some animals, I believe. The gestation, the plus below. Tell me if I miss it. I think I missed it. I missed it. The Scatterplot provided. Hey, here we go. Okay. So, Scatterplot stuff. Okay, 22, 23. Stat Tool 1, Chapter 8 quiz. The Scatterplot provided. Okay. Scatterplot provided shows the gestation period of life expectancy in some animals. I believe humans are included in this, while elephants and hippos are included. So this one might not have the human ones. There's elephant, there's hippos. Hippos looks to be more of a what? Think of your conditions for regression. QQ straight enough, no outliers, plot doesn't thicken. Hippos looks to be more of a what in this graphic right here. Hippos looks to be more of a what? Hippos looks to be more of a what? Outlier, yep. This is far away from the trend line, so you have to add your own trend line to this. And we can see hippos has a pretty big residuals. Residual means the actual minus the predicted, which is E residual. Make sure to know these ideas. And so they have a negative residual because below the line is negative, above the line is positive, and on the line is 0. Like elephants is perfectly on the line, so it has no residual. And I think they're going to get into how does this impact the line or the model. Let's look at that. And with that in mind, by removing one of these points, we could make the association pair stronger. So which one of these removed would make it stronger? Hippos or elephants? removing one of those would make it tighter, which is stronger. So which one of those could we remove to make it stronger? Hippos, yeah, because they're an outlier. Outliers can weaken relationships. So if you remove hippos, the relationship gets stronger because the points are tighter around the line. If you remove elephants, it would get weaker because that point is kind of nailing down the relationship. So removing hippos would make the association stronger, since hippos are more of a departure from the pattern. Hippos don't follow the pattern. Would the slope of the line increase or decrease? Now this is where it gets tricky, and I think they're doing a follow-up. Oh, look, they even say right there, like, it's pretty obvious because now we're talking about with the removal of hippos. So, so what hippos is doing, and I might have drawn this improperly, is because hippos is actually pulling the line towards it. So hippos has like this pull which brings the line down towards hippos. So the removal of hippos is going to pull the line back upwards because when you put hippos in, the line pulls towards it. Does that make sense, Noel? Think of like the model tries to get closer to the points. So by hippos existing right there, the model is going to pull downwards towards it because the line is trying to minimize the sums of squared error, or it's trying to make the residual smaller. So hippos existing pulls the line downwards. So it probably doesn't pull it downward that much because now elephants looks like an outlier, but it's going to decrease the slope because the point of hippos is below the regression line. Sure, because the point of hippos, and actually this one I take issue with. I've always taken issue with the way they word this. Because technically, if you had a point over here, let me redraw this. If you had a point way down here, then removal of this point would actually make the line go up. So the technical answer is it's above the mean of x, and it's too technical. It's not on the test. So it would the slope increase or decrease? So when we remove it, right? Would removing it. So removing it's going to make the slope go back up because it's not pulling towards it. The slope's going to increase because it's below the regression line. And that's a not 100% theoretical correct answer. Should we just keep removing animals to increase the strength? Yes or no? Should we just keep removing animals to change the strength? I don't like this question. If there's something we're going to get wrong, so they really don't give a great answer right here. Like, I don't know who wrote this question. I'm going to keep it because we got a video on it. It's possible I could get it wrong. Outliers always require special attention. You remove outliers when the data is wrong, when the data is not trustworthy. You can't just be removing outliers. You can't just make your model better by removing outliers. And you don't even have to remove something because it's an outlier. It's like if the data is wrong, you can remove it. If someone lied to you, you can remove their data, even if it follows the trend. So all data points for a model should always be kept. That's just theoretically wrong. You don't have to keep all data. You can remove outliers, or you can remove any data points. And this is just, you don't keep points that just strengthen it. Data points that aren't similar to the mean should be removed. No. The correct answer should be, this is their answer, I believe, but the correct answer is no. We must carefully consider all points in the model and validate them and only keep points we can trust for the data being accurate. So I don't know why we're removing it anyways. The slope of the scatter plot is 15.5. If we remove elephants from the scatter plot, the slope of the regression line is 11.6 days per year. Do you think elephants were influential on the slope? Well, it went from 15 to 11.6. If your hourly salary goes from $15.50 to $11.60, did something influential happen to your salary, yes or no? If your salary goes from 15.5 to 11.6, did something influential happen to your salary? Was your salary influenced? Yes. And that's what influential means. So yes, removing it lowered the slope. So yes, it was influential. And I don't like that one. I need to be more specific. Let me save this. Let's do some data analytics. Okay, if you are watching this right now, we're about to talk about data analytics. And with this, watch this segment. Don't just fast forward. You've already fast forwarded, haven't you? You haven't yet because you're watching this. With the data analytics 5, the number one thing you need to do is look at the rubric. The rubric is how you will be graded for every data analytics. So look at the rubric, see how you'll be graded on the rubric, and make sure to follow the rubric and look at the boxes that are being checked. And so let's start with some Data Analytics 5. Let me pull it up over here. And with Data Analytics 5, you're doing regression. So once again, I'm going to go back to doing some Pokemon data. And with Pokemon, you'll get to see analytics on Pokemon. Let me go here to Data Analytics 5. Taking me a moment. You're probably fast forwarding. Now you are. Okay, Data Analytics 5 pulled up. Let's go check it out. Here we go. So first off, I've got a video. Oh, there we go. Data Analytics 5. We're going to drop this in the chat right here. Extra help. And there it is right there. Data Analytics 5 extra help. We'll pin it as a comment. And you can see right here, you are doing data on engagement rings. Create a subset right there and follow these instructions. And I would highly suggest going down here to where you're graded. Once again, did you take a random sample? You can see your grade there. Did you put the information at the top, which you can just copy paste right here and then fill in? Was it the correct output? Did you show what we need you to show? Did you check all the conditions and do it in paragraph format right there? Did you interpret the y-intercept? And I would do, people have asked, how would you format this? I would do this as a paragraph right here. Then it's easy for the graders to see you did the conditions. Y-intercept I would do as its own paragraph. Slope-intercept I'd do as its own paragraph. I know those are very tiny paragraphs, but it really helps with the eyes to see like, okay, they did this, they did this. The R-squared interpretation and statistical significance and interpretation of statistical significance. And you did your write-up is accurate and then complete sentences and paragraph format. So you can see the buttons they're going to click and how you will get the points associated with it. Like slope and interpretation of it, super important, 3 points right there. So yes, and great job, Noel, right there. Make sure you follow this and look at the buttons that they will click. If you're getting the wrong values or wrong interpretations, that's where you're going to lose points. Let me open up that Pokemon data. I feel like we need the Pokemon like, I want to be the very best. We need that every time we open up this Pokemon data. Then we'll get copyright claimed. Okay, so in regression, so let's put the first thing in here. Conditions for regression. Okay, well, let's do starting the assignment. Okay, you need to be working with this semester the engagement ring data set and take a random sample size of 100. So let me double check that. It's 100 plus the last 2 of your UTID. I try to make as little errors as possible, but you're doing 100 plus the last 2 of your UTID, which can be done by going here to tables and then subset, tables subset, and under tables subset, type in 100 plus the last 2 of your UTID. Make sure it's the last 2 of your UTID. And then click the button and then click OK. You do not need to take a screenshot of this because we will see when you make your analysis that you have a sample size of your random sample size. Now don't use 123, use your random sample size that's associated with the last 2 of your UTID. Hence, if the last 2 of your UTID is like 91, it'll be 191. So we should see some number between 100 and 199 when we see your output. Don't screenshot this. So now we're going to do the analysis. Once again, remember, I'm using a different data set. So to do the analysis, we go to Analyze Fit Y by X. Why fit Y by X? Regression is the idea of making an equation y hat equals b0 plus b1x. Know that equation because we're going to be seeing it shortly here. That was y hat, the predicted value of y, equals b0, the value of the intercept, plus b1, b1 is the value of the slope, and x, the name of the x variable. Let's do this. So when you do your regression analysis, you're going to have the y variable of interest being price. You're going to have the x variable being caret. That's because caret explains why something is a certain price. Notice how we do that circle? Does caret explain why something is a certain price? We're interested in price. Maybe caret explains it. Well, I'm interested in attack power. I want some super strong Pokemon. And now I'm going to ask, does speed influence or explain attack? Maybe they have a negative relationship. Maybe fast Pokemon are not as strong. Maybe fast Pokemon are super strong. What is the relationship? Well, let's find out here by clicking OK and looking at the scatter plot. You can actually see what you're going to get down here via the combinations, mosaic plots for 2 categorical variables, side-by-side box plots for a categorical X, quantitative Y, 2 quantitative variables, Q straight enough, no outliers, regression, and then down here is what's called logistic when the Y variable is categorical and you fit the sigmoidal curve. That's a different type of thing, which we do in 320. Let's click OK. Looks a little weaker, a little bit of outliers over here. If I had to draw a line, here I'm going to see how I do it drawing my line. I put a lot of lines to data. How close will I get? So you want to think, does it look linear? Does there look to be outliers? You're going to fit the line here in a second. This is just me doing a little extra. We're going to go right here and we're going to put a line like that. Let's see how our fit line goes when we go to fit line here. And oh no, the more accurate line is, oh, I don't want to move it. I want to draw on it. More accurate line's that. I was hoping I'd do it like perfectly. I've seen a lot of lines in my day. So with this right here, there's our regression plot. So the regression plot shows you, and once again, if you didn't see what I did, I went to fit line to fit the linear model to the data, fit line. One thing you can do if you want to investigate nonlinearity, and it's kind of cool, you could even make a screenshot if you want. Graders should not take off for this. But if you're wondering, is it linear? There's a way to look into this. Here's how to see if something's linear. First off, using your eyes. Do you see some sort of nonlinear pattern? Do you see some sort of wee through the data? I really don't for this. My data looks linear because it looks to follow a linear pattern. You can, however, and this is extra, this is not required, just me being extra, go here to fit flexible and fit a spline. I think you can choose any one of these values right here. That's fit flexible, fit spline, and choose a value. And then what we're going to do is we're going to go down to this adjuster and we're going to see if we really see. See, there's that light bend at the end and it'll always get more bendy, but really the line looks good. It's just when you go down to here, it gets crazy and it overfits. Notice the R squared is actually going higher, but I'm really not seeing, you have to go pretty darn low. And I think it's just pushing towards outliers. It's just, mostly it's linear. There's just some weirdness at the end. It's really that point. In truth, this point right there is what it's pressing towards. If that point didn't exist, it would still go normal. So we're going to remove this out. That's just a way to investigate. And you don't want to overly look at stuff. You want to see if what you see makes sense. And the line looks to be good. There's that weird point there. There's a weird point up here. And let's even do a little bit extra right here, because how do you know where to start drawing the line? It's not corner to, nope, not corner to corner. So the line is going to fit itself. The line is going to go through the middle of the data. So you don't have to know how to draw it. It's just something you learn over time. The line's going to try to get as close as it can to all these points. So some are going to be below negative residuals. Some are going to be above. And it's just practice on learning how to look at it. And I actually didn't do that good of a job. If I were to rank myself, I would give myself a C+. I could have done a lot better on drawing that line. I'm going to mark some outliers here. I'm going to highlight one right here. That's a point I want to say is a little bit odd. I'm going to go here to rows, markers, and click this right here. And then rows, colors, and I'm going to go to, let's go to a light purple right there. You notice that point. I'm going to highlight more by holding and dragging. Then I'm going to hold Control and select this. And maybe over here. And there we go right there. So now I'm going to go to rows. So wherever kind of, the middle of the data is where the line goes through, and the line figures that out for you. This, everything I'm doing right here is not required. So if you've already done the assignment, you didn't do this, not required. What is Brian trying to accomplish right now? He's trying to mark some of his what's-is. Brian is trying to mark some of his what's-is right now. What am I doing? What is the point of this? Why am I doing this? I'm trying to mark and make clear where there's outliers. Outliers are the things that are furthest away from the line. One last thing we're going to do right here with our getting started and making the output is we're going to click down here, and under the fit line, we're going to go to plot residuals. And notice, if you notice in this residual plot, which we'll take a picture of, in this residual plot, and I didn't want to do that one. You want to grab right there. There we go. I was going for it. I've marked the ones with the greatest residuals. Notice that this one has a residual of a little over 60. It's maybe 65. This one has a residual of like negative 55. How do I know that? You trace over here and you can see where it hits the axis on what its residual is. So the residual is how much above or below something is to the line. And we could even look at this point down here, which you can see right there, and it has a residual of 1. What is the residual of this point? it was predicted to have an attack power of 95 or so, maybe 95. If you trace over here, it's prediction of 95, and it maybe has an attack of 55. So be careful. 95 and 55, its residual is what? I'm estimating, looking at it, and it's a little bit obvious if you look over there, its residual is what for this point, helping us understand that the actual is 55 by my estimates, and the predicted is 95 by my estimate. Noel, and that's the thing I want to point out, and good answer is it's close to 40. 40 is the residual of maybe this point. Notice how that point has a residual of about 40. This point has a residual of what? Not 40, residual of what? Because this point has a residual of 40. This point right down here, remember, down here has a residual of what? Negative 40, because it's below the line. When something has a negative residual, its predicted is higher. The predicted is the line. So a negative residual means below the line. Positive residual means point actual above the line. So residuals are always a distance. And when we look at what a residual is, the residual is the formula, actual minus predicted. So residual equals actual minus predicted, and actual is a point. A predicted is a value on the line that you trace up to when you go to the X, and then E is the residual. No worries, no worries. Yeah, and you can look at the distance and then think, is it above or below the line? Because actual or residual is E, and actual is Y, and predicted is Y hat. So sometimes I mix up the notation. Sorry, I did that right there. We would say residual if we did it with this notation, or you could say that the prediction from the line is the prediction and the point is the actual and the residual is the E. So make sure to understand residual equals actual minus predicted. Very important things right there. So now we have to check the 4 conditions. Now I'd write them out, might even bold them to let the grader know I'm doing the 4 conditions. What are the 4 conditions we check to make sure we're doing a valid regression? So let's put this, getting the output. What are the 4 conditions we check to do a valid linear regression? Say them in the chat, practice them. The force. What are the 4 conditions? What are they? The 4 conditions. Make sure to know how to write them out. Make sure to know how to explain them. What are the 4 conditions for a valid linear regression? Those are interpretations. So a lot of times when doing regression, so those are what we usually interpret and explain about the regression. We interpret the slope, we interpret the R-squared, we interpret the intercept. The 4 conditions are QQ straight enough, no outliers, plot doesn't thicken. Because we have to meet these conditions to be doing regression and be doing it properly. What does QQ mean? QQ, you hear me say QQ a lot, and the notes call it 2 quantitative variables. It's just easy to remember QQ, as in, is speed quantitative? Is attack quantitative? Yeah, because they're both numeric values. So via that, we get a scatter plot. I'm like, I hope everyone doesn't write exactly, don't write exactly what I write. Don't copy what I write here. Don't copy copy what Brian says. So don't copy exactly what I say. Don't do that. Think about it. I can say this 4 different ways. Speed and attack are both quantitative values, so we meet 2 quantitative variables. The 2 quantitative variable condition states that we need both variables to be quantitative, which speed and attack are. To check QQ, which means 2 quantitative variables, we need to look to see speed and attack are quantitative, and both are. To make a scatter plot, it is required that both variables be quantitative, and to fit the regression model, we need that, and we meet the condition because speed and attack are quantitative. Notice how I'm justifying it that we meet the condition because speed and attack are both quantitative variables, and there's an infinite number of ways to say this. So take this in, understand the condition, and then write your own words on each condition, because I can say each one 4 different ways, which means I understand it. I'm not just writing out what someone says to put in blanks. So what comes after QQ? What is the next condition after QQ? QQ. I'm gonna do 3 different ways for each one. What is the next thing for QQ? After QQ, we have to have 2 quantitative variables to do a valid regression. We can't even do regression if they're not quantitative. What's the next condition? QQ. What's the next condition? Straight enough. Straight enough means that you could have something that has a little bit of a bend in it. Like maybe it goes like that. And you know what? This is probably straight enough. It doesn't have to be perfect. So you might say, well, Brian, you said your model might have this little boop there. Okay, that's fine. I'm going to write my own. See, you can't copy me now because I'm going to say, even though my model has a little weird boop at around 130, that little boop, your model probably doesn't have boops. Don't mention boops in your write-up. Boops is not professional, like in the business sense. Even though it has that little whoop right there, I still think it's straight enough because the line approximates the line is a good representation of the majority of the data, aside from that little boop, which we'll just forgive for now. That's what I'm gonna write my write. I'll say, I forgive the boop. Don't write that stuff. You know what I'm saying, though. You know what I'm saying. It's straight enough. This little sad point right there is not enough to make me doubt the line. I think the line is still good enough. How about them outliers? QQ straight enough, no outliers, plot doesn't thicken. Now, when we look for outliers, we look for extreme things. We want outliers that are, well, we don't want them. But when we say no outliers, we say we don't want outliers. And if we're saying there's a problem with outliers, then we're saying there's something far away. It just depends on how big it is. Problems with straight enough are going to be seen where your model really has some sort of bend in it. Problems with straight enough are going to be like, that is not straight enough. That is not straight enough. Both those are clearly, the bottom one especially. The top one has it's still got a pretty big issue. It's a nonlinear exponential model, monotonic, all those fun words. Both those ones on the far left have problems. This one up there is your perfect regression. This one, the one I have right here, is pretty darn good because outliers are things that are really far away. Like you can have an outlier over there, you can have an outlier down there. There's only moderate to light outliers. Notice that everything I did right here doesn't have an extreme value. There's no extreme points that have huge residuals. They're just kind of a little further away, and there's always going to be a furthest point unless they're all zero. But this is not that extreme. None of the values I have noted, none of the values that I've highlighted show that they're extreme outliers. I don't think there's problems with outliers. We passed the no outlier condition. I do not see any major issues in my regression. I've noted points that have the biggest outliers. Yeah. I do not think there's an issue. The points that look to be far away are not that far away. There's not a big issue. How about plot doesn't thicken? Where do we analyze plot doesn't thicken? Where do we analyze plot doesn't thicken? QQ straight enough, no outliers, plot doesn't thicken. Once again, another teaching to the test moment. Where do we analyze plot doesn't thicken? I'm right there, right now, I'm at that spot. Where do we analyze plot doesn't thicken? QQ straight enough, no outliers, plot doesn't thicken. QQ straight enough, no residual plot, exactly. And there's multiple types of residual plots. I just used the first one. And what we want to see here is that the thickness of the residual plot is about the same throughout. Now, 1 point is not really a good way to analyze the relationship of the data. For the most part, except near the very end, there's a small problem here, but it's probably due to a lack of data. So really, when it comes down to it, the majority of the data, or at least the bulk of the data, seems to show the same thickness. When we have a problem with plot thickening, you're usually going to see a residual plot that looks something like this. It could get thicker or thinner. And people say, well, what if it gets thicker and then thinner? So if you saw like something like this right here, people say, well, it goes back. No. This would also be very bad. You don't want it to have a thickness that changes throughout, and you want enough data to be able to analyze that the thickness has changed. As in, you're not going to make decisions about the thickness right in here because you only have 1 point, so you can't really tell the scatter of data. So in truth, we really can't analyze in this area. So the bulk of the data is contained within here, and it looks to have about the same thickness. Same there, we have very limited data. So you can't analyze a pattern of spread with 1 data point. So I'd say the bulk of the data, at least for mine, shows the same thickness, whereas these plots have huge problems. If you see anything like the 2 plots I drew in orange, you've got big problems. What you ideally want to see, so we judge it based on the, yes, if you only have like 1 or 2 data points, what I'm saying, does it make sense when I say bulk of data? Here, I'll highlight 2 sections. I'll make it very clear what I'm showing. Like, let's go, because to analyze spread, you need multiple data points to analyze what the spread of data is. So I should just re-screenshot at that point. If you look at between here and here, and you look at in section 1 and section 2, where do you have more data? Section 1, right? Section 2 is even a bigger window. So it's easier to understand the spread of Windows section 1 versus the spread of Windows section 2. You might say, well, this has less spread, but there's only 2 data points. And if you do the same thing, you do a segment here and a segment here and a segment there, you would say, well, the spread of the data here goes from here to here, here to here, here to here. And if you look, it looks very similar between all sections except the last one. But the last one, we really don't have any data to judge the spread by. So it might be better to just do like windows and then say, well, in this window, I don't really have a lot of information. Once again, we will make it very clear if there's a problem. Like if you see this right here, in Stat Tool 1, we just go for like very clear visual differences. Notice how we do our idea of like segmented windows. We'll do a different color for the segment. If you go like here and here and here, all the windows have about the same amount of data in them, the same amount of points. So you'd say it's about there to there, there to there, there to there. And you can notice the plot's getting a lot thinner. What happens if the data at the end is very tight? That means the model is getting stronger. So that model up there has an increasing strength, what I think chapter 7 and 8 covers somewhat when they're doing residual plots. The model is increasing in predictive power because the data is getting tighter around the line. This blue line down the center of this is your regression model. And you can see this if we go back to the data. This blue line right here, remember these 2 points, one is slightly below, the other's below. That is literally your regression model made flat. Check out our class where we did chapter 7 residual plots, and we talk about how this plot is made where you make the line flat and then set it equal to 0. So if you see the model getting tighter around the end of it, it shows that the model's predictive power is increasing because the points are getting tighter around the line. Good stuff. There's the 4 conditions. QQ straight enough, no outliers, plot doesn't thicken. Know how to explain them all. Okay, we're on to the next section right here. Interpreting values. So we got 4 things to interpret now. We've got 4 things, and you need to make sure you do not need the analysis of variance. We need to make sure we have the equation. So if you're wondering at this point, what output do you need? Mike Wiseman's over there. Who is that? This is Mike Wiseman. He's great. You need the plot. Taking screenshots. And we'll make this smaller. Might even check the conditions right here. That's a good spot to check the conditions. And then you could even do like a new page or something and go down to here and do interpretations. Oh, and then I would also put your residual plot up here. So I would probably organize this where I put my residual plot by diagnostics. And if you want to be really fancy, so I'd check the conditions, and then you could even mention with condition 4. One thing you could do also, since we're going for size, is you could stretch this out a little bit more to there, and now re-screenshot. So I like my stuff to look very pretty. And here we go. There we go. Really? Wait, wrong thing. There we go. There we go. And get these nice and neat. Get them centered. Make them clear and easy to read. Center your plots. Throw a little background on it. Gotta be careful, it might cut it off. No, I don't like, gotta be careful. Some things can be distracting, like that. That's distracting. And maybe I won't use these features today. Oh, it's not bad. Yeah, it's whatever you want. Wish it had a quick, you just selected this. That's good. Okay. We'll go here and do the same output. There we go. Like that one. Okay. And there it is, and center it up. we'll call this section screenshots and screenshots making look good. Okay. There we go. Oh, and do not forget, at the very start of the assignment, you need this information here, and I would just copy paste and fill in. Go. Can you please show all the parts that is needed to be in the screenshot? And so I think I have everything now. So just reviewing the screenshots, I wouldn't center those. Reviewing the screenshots are going to be your regression plot. You need the regression plot right here. That's a necessary screenshot. Your plot by residuals, necessary screenshot. And then also the linear fit. You do not need the analysis variance. You don't lose if you get points there. You don't need the lack of fit. You need your R squared with your model and along with the slope and intercept down there. So there you go. So once again, that was your scatter plot is needed. Scatter plot. You need residual plot. And you also need the linear fit. Okay. And now let's continue on here. We are at the 53, Stat Tool 1, interpreting the regression. Okay. So with this right here, I wish Meebot was in the chat so he could say these things. There are 12 points on exam 2 for interpreting your regression. I don't think we've changed the exam. I know I'm going to keep it that way for my section. But you have the slope, the intercept, and the R squared. And let's write out the blank interpretations for them. And this is where we do see similarities in interpretations for people. So you will have very similar interpretations. Don't copy anybody. Do not look at anybody's assignment. You're watching this video here. So if you use what I use, you shouldn't get in trouble. We talk as instructors and we make sure everyone knows, hey, Brian said this in this video, but notice how I haven't written anything out up here with the conditions, other things you're thinking. So the interpretations are usually pretty similar because we want to make sure you get them right. So let's start here with the slope first. And it's going to be for each 1 unit increase in X, we expect Y to increase/decrease by B1 units. The intercept is going to be, now Noel, should you write, is this what you're going to write on yours and you get all the points? Is that what you write and you get all the points? Yes or no? When X is equal I got to add an on average right there. Some people take off for the on average. Well, these aren't conditions. This is interpretations of values. These are, the conditions are all the way up here. The conditions, you're going to put all your conditions in here, full paragraph format. You're going to interpret these right here. You're going to write your own sentences on them. You're going to use what I'm doing as a kind of structure and fill it in. So these correct. And then intercept R squared, blank percent of the variation in X or Y is explained by the variation in X. And then statistical okay. So we've got all the help we need for all these values, which are very important, which is a large portion of this chapter. Now, when you go up here, you need to know how to look at your model. And Noel, what is the intercept? Just what is the intercept? Just what is the value of the intercept? What is the value of the intercept? What is the value of the intercept? Correct, because that's B0. This is B0 plus B1x. This is the y hat right here, so attack is the predicted value of y. Great job, that's the slope, you got it. And these are the values we need to learn how to identify and output. So if you notice here, I'm just showing that we can go through and start marking things of importance. Like this is the name of the x variable right there. That's the name of the x. And we can mark where the r squared is at. I think I'm getting most everything. and it needs to be times 100. And check the p-value of the slope. Slope, it's this value right there. Here I'll circle it because it's going away if I do that. And the slope is the x variable. So the x variable right there, and that's the x right there. And then I think we have it. I think we've got everything highlighted. Okay. So if you notice, we've highlighted all of our output right here. At this point, we just have to know what to put in where. So we don't need to find the r-squared because it's already, yeah. R-squared is already given to you. R-squared is right there. There it is. Okay, do you want to try any of these interpretations? Because you have to write them out on the test. So just knowing how to do them, you get practice just trying any. I wish Mubot was here to give points. We'll get him back one of these days. We'll save him from the multiverse. But you have to know how to do these and interpret these for the test. Yeah, Noel, great job. And so this, I beg people this because people get to this, say, I say interpret the slope, and they say 50.92, which I said, what is the slope earlier? I said, what is the slope? So Noel was perfect in that answer. If I say, what is the slope? The answer is 50.92. But if I say, oh, no, that's the intercept. See, I'm going wrong. If I say, what is the intercept is 50.92. If I say, what is the slope is 0.44. But if I say, interpret the slope, the interpretation is different. So you have to think when I say interpret the slope, what does that mean? Interpret the slope. So if I say interpret the slope, what does that mean? If I say interpret the slope, interpret. So interpret the slope would be for each 1 unit increase in the Pokemon's speed. Notice how I'm throwing a little extra right there because I'm talking speed of Pokemon, giving it context. For each 1 unit increase in the Pokemon's speed, we expect the attack power of the Pokemon to increase by 0.44 on average. So once again, that was for each 1 unit increase in the speed of a Pokemon, we expect its attack power to increase, because it's positive slope, by 0.44 on average. The intercept would be when a Pokemon's speed is equal to 0, we expect its attack power to equal 50.92. When a Pokemon's speed is equal to 0, we expect its attack power to equal 50.92. I don't think this is logical because even, what's that one? Slowpoke and Slowbro and Snorlax. I don't think any Pokemon has a speed of 0. I don't think there's a Pokemon with a 0 speed. So I think this is an extrapolation. There's no Pokemon with speed 0. So I think that's not logical. The r-squared is going to be 14.5. I'm rounding it. I'm timesing it by 100. So all you do is you go right here. You take times by 100, 14.5 when rounded. 14.5% of the variation in attack power is explained by the variation in speed. That's all there is to it. Now, statistical significance is when the p-value is below 0.05. So because the p-value of the slope is 0.001, then the slope is statistically significant, letting us know the model is statistically significant, and we think that speed gives us important information about the attack power. Don't copy what I said, though. Don't copy what I said there. Notice I didn't give you, because there's a billion ways to say that. Like, yes, the model is statistically significant. The one thing you're going to have to mention is the p-value. And the p-value needs to be below 0.05, and it needs to be for the slope, so I would quote those. So if you look at the important things to know about the statistical significance of a regression model, it's going to be that the p-value of the slope variable is below 0.05. So that is very, very, very important right there. So I think the grader shouldn't take off if you do it. I wouldn't do it this way. You might say something like, this right here. Like the interpretation of this is this. You might put it in paragraph format. Like make it look nice and pretty right there. But they want paragraph format. I'm going to write down here You can argue points if you lose them, but use paragraph format. I don't want anyone to lose. I'm just bullet pointing right now because the assignment does say use paragraph format. It's just easier for you to see the structure and to think like, you know, my slope means this, my intercept means this. And then up here when checking the conditions, you know, I don't want to write everything out because then people start compromise. There's a way to check the p-value you mentioned in your previous video that you can hover over it. You show, oh, yeah. You have to do the circle trick. Yeah, that's, so to get the exact p-value, you click on it one time and then you hover back over. And so my exact p-value is 0.000, it's got 4 zeros there, 14. It's basically 0. But that's the p-value. And also, you might just say the p-value is less than 0.0001 because sadly, a grader might get confused. So I'm always worried about the graders being like, well, your p-value doesn't say that. It says less than 0.0001. And they didn't know you did the hover trick right there. So, yeah. Also, 4.53 squared is actually 20.51. How do I know that? Because the f is the square of the t. Don't put that in your report. 4.53 squared is there. It is right there. It didn't get enough decimals on it. So if we go 20.5152 square root, there you go. Oh, wait. Yeah. There you go. Well, with that, we're going to end office hours. I'm going to go to class. Noel, great job. Let's save this. Send me those questions if you got them and keep up the good work. Bye for now, everyone. Bye.